Hey guys, welcome to my channel Quickie. Today we will be learning about supervised learning and how machines use labeled data to make accurate predictions. Let's get started. Machine learning is actually a branch of artificial intelligence that enables computers to learn from data and make decisions or predictions without being explicitly programmed. Instead of writing a code to tell the computer exactly what to do, you provide data and let the computer to learn patterns from it. Imagine you want to teach a computer to recognize whether an email is a spam or not. Instead of writing detailed rules for spam detection, you provide the computer with many examples of emails being labeled as spam or not spam. The computer then learns to identify the characteristics of spam emails based on those examples. Basically, machine learning relies on data to learn and make decisions. It actually identifies patterns in the given data and uses those patterns to make decisions or predictions on new or any unknown data. Machine learning models can actually improve over time as they get exposed to more data. There are three main types of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. Today, we will focus exclusively on supervised learning. Other types of machine learning will be covered in upcoming videos. Now that we have a basic understanding of machine learning, let's dive deeper into supervised learning. Supervised learning is basically a type of machine learning where the model is trained using labeled data. Each training example dataset includes an input and the correct output, and the model learns to map the input to the output. Now let's see how the supervised learning actually works. Step 1 is your training data. The training data consists of pairs of inputs, which is being called as features in the context of supervised learning. I repeat, the training data consists of pairs of inputs, which is being called as features in the context of supervised learning. And we also have correct outputs, which is being called as labels in the context of supervised learning. For example, if you're training a model to predict house prices, the input features might include the size of the house, number of bedrooms, and location, while the output label would be the actual market price of that particular house being listed on a real estate site. Now let's move on to the next step, which is learning process. The supervised learning algorithm analyzes the training data and learns the relationship between the input and the output. This learning process involves finding patterns or rules that map the inputs to the correct output. Finally, we move on to the next step, which is the prediction stage. Once the model has been trained, it can be used to make predictions on new or unknown or unseen data. For example, given the features of an unknown house, the model can predict its price based on the training it has received. Once all of this is completed, it moves on to the feedback loop. Here, if anything is found to be out of place, it gets further fine-tuned, and once it has been refined, it is then brought back to the original state of training and getting the system more exposed to the live environment. It's just kind of a feedback mechanism loop where the system gets improved upon in its prediction over a period of time. Now, to understand the supervised learning better, let's compare it with unsupervised learning. You see, supervised learning uses labeled data with accurate input-output pairs to train the prediction model, whereas your unsupervised learning uses unlabeled data, that is only inputs, no outputs. I hope you get that. When it comes to your supervised learning, the goal is to learn how to actually map the input to the output using historical data so it can make predictions on new or any unseen data. Whereas when it comes to your unsupervised learning, it actually analyzes the data to identify hidden patterns and it will try to make some sense out of it without having any kind of labeled output. It actually groups similar data points together to uncover underlying relationships between the input and output, and then it makes its own prediction on its own. Sometimes the prediction could go wrong, but it gets better over a period of time through multiple iterations. And when it comes to your supervised learning, some of your common examples could be your email spam filtering, predicting house prices, classifying images of a given animal, could be say cat or a dog in a given picture, etc. On the other side, which is your unsupervised learning, some of your common examples could be clustering your customers into segments for marketing or reducing the dimensionality of a data for visualization. Now let's see some real world examples of supervised learning. Imagine you are actually managing a retail store and you are facing the challenge of balancing the inventory to meet customer demand while minimizing the cost and stockouts. You have a tons of data at your fingertips, including sales history, inventory levels, promotions, and external factors like weather, holiday seasons, peak season, low season, etc. The big question over here is, how do you predict the future demand accurately for each product that is being sold from your store? Now let's see how is the solution being provided for this particular problem using your supervised learning technique. It is actually a 5-step process. Step 1 is basically data collection and preparation. In this step, we will be gathering all the relevant data. This includes your historical sales, data, inventory levels, data about your past promotions, external factors like your weather conditions or your peak seasons, dull seasons, etc. Once we have our data, we clean it up and prepare it for analysis. Next step is your feature engineering. Here, we actually identify the features or the variables that could actually influence the demand, such as sales trends, promotional activities, seasonality, and external factors like your weather conditions, which is affecting the people's nature of buying products and things like that. We might create new features like lagged sales or indicator variables also for our promotion purpose. Now next move to the third step, which is your model selection. Now it's actually the time to choose the right model for our problem. Since we are dealing with the demand prediction, a regression algorithm like linear regression or a more advanced method like gradient boosting could be suitable. We select the model based on its ability to handle our data and produce accurate predictions. Next, we move to the fourth step, which is your model training and validation. With our model being selected, we split our data into training and testing sets. I repeat, we split our model being selected into, the data that is being selected into training and testing sets. We train the model on the training data, adjusting its parameters to minimize errors. Then we validate the model's performance using the testing data to ensure it generalizes well to the new or unseen data. Finally, we move to the prediction and optimization stage. Once our model is trained and validated, we use it to predict future demand for each product. These predictions help us optimize inventory levels, plan replenishment orders efficiently, and also allocate resources effectively. By accurately forecasting demand, we can reduce cost, minimize stockouts, and improve our customer satisfaction to the next level. And there you have it, folks. We have explored how supervised learning can be applied to solve real life challenges like optimizing inventory management in retail stores. If you find this video helpful, don't forget to like, share, and subscribe to Quickie for more insights into the fascinating world of machine learning and data science. Thanks for watching. I'll see you in the next video. Happy learning. Good day.